Hey guys, welcome back to the shop. So we just finished turning the OD on all of these big aluminum discs. These are 1-inch thick plasma cut aluminum, and we've already got the OD finished and one side faced off. Took about 30 thousandths to clean off all 8 of them, and we're getting ready to start on the 2 fixture plates. This is most likely going to be 2 separate videos. We'll focus on 1 fixture plate, and then we'll focus on the 2nd fixture plate. Then of course we need to get to the actual machine work of the work pieces here. But the fixtures themselves are jobs in themselves, and I plan on using our Flex CNC for this guy. And then this round fixture here, we're going to go to the American Pacemaker and do all of our face work there, and then we'll go to the mill to put our hole pattern in there. So a quick rundown of what we're going to be doing with these fixtures is, so by the way, this is the sample piece that I'm copying right here, and we'll talk about that here in just a second. So we're going to have fixture 1 and fixture 2. This is going to be our first setup. This is going to be our 2nd setup. So our first setup, once we get this fixture machined here, I'll be able to take our aluminum disc that we've already turned on the OD, and it's going to have a counter bore inside here that this will drop into to center it up. And I plan on having 4 strap clamps to hold the outside of the plate here. So we'll have a clamp in each corner there to hold it down. We're also going to have some holes drilled in this, and this will be bolted directly down to the CNC mill over there. So we'll clamp it on the outside. We're going to machine this inside, this ID here. So you got a counter bore that's 3/4 deep. I can't recall exactly what the diameter is, but I've got it on my print over there. We have a hole pattern that we have to drill in there. And once all that is finished, we'll do all 8 of those, get all of them machined. Then we'll remove it from this fixture. We're going to have this round fixture that'll be bolted down next to it, and I'm going to have it turned so that there's a boss on here, a registered fit that's going to fit the ID of the ring right here. So we'll be able to take it off this fixture, set it on this one. It'll line up on that registered fit in the center, and then I've already got this clamping ring drilled right here. This is what's going to pull it down. I do plan on putting this in the lathe. I'm going to face this off flat so that I know I've got a good flat surface to pull down on this machine face right here. So we'll just set this down inside like that, and we're going to use 6 bolts in this steel ring to clamp it down, and then that leaves this outside area open, so we have a taper across this face right here, or an angular surface. And my goal is to use the Flex CNC to machine this outside right here. This is traditionally done in a lathe, and that's how the sample part was done as well. Whoever made this, they actually turned that in a lathe, and it's a great way to do it. And if for some reason my plan for doing the CNC mill here doesn't work out, I'm not getting a good finish, or I'm getting chatter or any kind of problem like that, then I'm going to back up and rethink what I'm doing and probably just go to the lathe. We can use this fixture right here if we need to chuck it up, bolt it on there, and actually just use the compound to turn that. But that's my backup plan, because I want to utilize my CNC mill to get this job done. So that is the plan of attack. We're going to start on this guy today. I've got some new work holding magnets set up over there in the Flex CNC that I've already milled off. We took about 5 thousandths off the top of those magnets over there, and we will set this plate directly on those 4 magnets, mag it down, and I'm going to mill the back side. We're just going to face it off. I'm going to put my 4 hold down bolts or holes in there for our studs. Then we're going to flip it over and finish out the other side. So that's the plan of attack. Let's get down to the Flex and get started on it. So here's our new work holding magnets made by Earthchain, the ECB 120s. I already got them set up, squared up, and I've already run the face mill across all 4 of these guys. And Technics recommends that you do that. I did check them once they were mounted up here, and they were about 4 thousandths difference on height there. So we just touched off on this one, took 5 thousandths, so we got a nice flat plane across there, and we're going to use this to help get our 2 fixture plates machined. I have absolutely been loving my new earth chain magnets. That is such a nice upgrade from my old Magmate that I've been using forever. Let's see if we can eyeball this sucker and get it right the first time here. That don't look too bad at all. And of course we got our lovely sky hook. It's helped us jobs just like this right here. That's why we have it, so that we can take these work pieces and be able to pick them up from somewhere here in the shop and then roll them right on down to the machine, which I'm going to show you right now. The forklift is, I just don't have a lot of room in the shop here for the forklift, so getting things like this from the forklift right over here to the table where I can work on them is where the sky hook comes in. And of course we can pick them up, roll them right down to the flex, and set them right on there. It is a lot of gravity to move around though with all these counterweights on this guy. Yep, we got them. I've already got the magnets spaced accordingly so that whenever we drill our 4 hold down holes, it's not going to hit the magnets there. All right, first thing we'll do is we need to get it pretty well centered up on our magnets, and then once we get it centered up pretty good and square, we'll go ahead and indicate the front edge here and make sure that it's nice and square to the axis, the x-axis there. So we'll just use a scale here and measure both sides. Pretty close. 3 inches. 3 1/8, so we went a little bit too far. Let's see if we can get 3 1/16. That looks like 3 1/16. Flip it around so I can see the 3. That looks like 3 1/16. So we're centered that way. I can tell it's off just a hair. So this dimension is probably going to be a little bit off here. So we got 3 inches. Tell that it's back a little bit too far. So I've got it squared up using just a scale here. It's right on about 3 1/16 on all 4 sides off the magnet, so it's pretty square. Now let's get this squared up. So we're going to use our Starrett number 257 surface gauge, and I've got a number 196 back plunge indicator attached to it. And I'm going to be utilizing these 2 pins here, setting it down into the rail of the machine, just like this. So the 2 pins acts like a fence, so it keeps the gauge square. And we're going to come up to this side right here, and we'll just sweep up and down, getting this thing bump straight. So we'll use our fine adjust, get a 0 set, and we just simply can slide it down, and you can get your reading Looks like we're about a 1/16 off, so it's about a 1/16 short on that side right there. So we'll just do a little bit of bumping to get it indicated. Or you can bump that side there. I think we'll just go ahead and take this side and go ahead and kind of bump it this way just a little bit. Only thing holding it in place is just gravity right now. I don't have the, you know, it's not like when you're using clamps, you can usually put just a little bit of tension on there to kind of keep it from sliding around more than you want. But with the magnets, it's simply on or off. All right, so we're reading +2 on the dial. We'll come down here and see where we're at, and not bad at all. You can see it's not straight. This is a plasma cut edge there, but we just want to kind of get it about straight on both ends. So I went a little bit too far, so I'll come down to this end and just ever so gently tap it. Give it the old taparoo, right? Get down here to this side, we just want to kind of average it out. It seems like this little area kind of drops off, so I think I'm just going to go to somewhere about right here, which is about -5. That's still +2, so all right, so we're -4, and that's about -4, -5, so we're averaged pretty nice on our indicator. Go ahead and give you a shot of that so we can see. It's about -4 there. And we come down here to that end and we're about the same on that. Let's see, now it's showing 0. I may have told you guys wrong. Let's go to about right here. So I think that's close enough. You're plus or minus a few thou, but we're nice and squared up. So before I do anything else and touch it, we'll go ahead and turn our mags on. I got to get the tool for that. So comes with you've got these hex extensions, you've got a T-handle there, and by the way, if I did not mention it, they're daisy chained together in the center, so they're coupled together, the hexes are. So once you engage this magnet, it's going to engage that one at the same time. So what we can do is just go ahead and stick that on there. I'm going to take our rule off out of the way. All right, we got a little red dot indicating that it's in the on position. Let's go ahead and move our surface gauge out of the way. And we'll do the same on this guy right here. There we go. All right, should be on. I can't validate these are on, but they're coupled together, so you know they got to be. I'm pulling on it and it is not moving. So it should be there. So each one of these guys, these are the ECB 120. I believe that's 120 kilograms. Hold down power, which equates around 2,600 pounds of downforce there, pulling power. So it should provide plenty of holding power to do what we're going to be doing. We're just going to be decking this off. I've got our program written so that we're going to take 20 thousandths face cut. We're just going to do a facing op with our face mill, and then we'll come in here and drill our 4 5/8 holes. And then once we get that done, I am going to drill a hole in the center of this, and we'll be between the magnets. See, I'm going to put a 9/16 hole in the center. I've got a 9/16 carbide drill that I'm using for some of this, so it'll make a nice hole, and that's going to be our centering hole for whenever we flip this guy over. We can center it up on that in our X and Y. All right, so I think we're ready to start doing some face milling on this guy. Let's give you a rundown of the machining for our first fixture plate here. So again, a big thanks to Kevin over at mechanicaladvantage.com for helping me with my training. I can highly recommend Kevin. If you guys are looking for some Fusion 360 training, please check out his website. I'm sure he can give you a hand with whatever you need for the Fusion side of the CAD software. All right, so I've got our fixture Op.1. So this is going to be the bottom side, and then once we get through the bottom side, we will flip it over, and that's what the top side is going to look like right there. So let's just start with the bottom side, and what we're going to do is come in here and face it. We're going to use a 3-inch Tungaloy face mill for that. All right, and then we're going to go ahead and spot drill the 4 holes. So what I have done is I went ahead and installed one of these guys. So this is a new Cleveland 120-degree spot drill. This is a 1/2 inch diameter, so I've got one of these loaded up in the machine, so we can use this for pretty much all of our spot drills. This is the proper spot drill whenever we're going to be using our 118-degree drill bits. So our jobber drills, this would be perfect for that right there. All right, so we're going to go in there and spot the 4 holes. After that, we will use a 41/64 reduced shank drill bit, high-speed steel, to drill our holes. That's going to be a clearance hole for a 5/8 stud. That's the hardware that I use on the Flex CNC. I also use 1/2 inch, but I like using the 5/8 whenever I can. So we're just going to have those 4 holes for our hold down stud, and then in the center right there, we're going to drill us a 9/16 diameter hole. That's going to be a carbide drill, and that hole is just used to center the plate whenever we flip it back over. All right, and then once we drill that, we're going to do a chamfer to chamfer those 4 outside holes and the center hole right there. So we can go ahead and simulate this, and you can see what it's going to look like. Blue indicating our stock there, and the green indicating the finished surfaces. Let's go ahead and speed this up. You can see we're going to have quite a few paths to make across there. Fusion's saying this is going to take about 14 minutes to do, so we'll just see how that goes. All right, then we're going to come in here. That's our 1/2 inch 120-degree spot drill. We're just going to spot the 4 outer holes. We're not going to spot the center because you don't need that with a 140-degree carbide drill. All right, that is our 41/64 high-speed steel drill bit, and we're going to be using a chip break cycle on that, so it'll break the chips. I've got it set so it goes down 1/8 of an inch and then it breaks. All right, so then we drilled the center hole with our 9/16, and now we're using our I use a 3/8 diameter mill drill to do our chamfers. Same thing you've seen me use before. That's what that tool is there. So that's the end of the program. That'll be the bottom, so we'll get this done, and then once we're through with that, then we can go ahead and flip this guy over, and then we can start on machining this right here. We're going to have some pockets to mill in here, and some drilled holes and some drilled and tapped holes. I've got this corner set for our work coordinate systems. We're going to be setting this as G54. The next fixture we'll do G55. So we're just using our hand pendant here and our Heimer 3D sensor. Go ahead and find the edge of Y and find the edge of X. All right, that's going to be our X0. All right, we got X0 located. Go ahead and back off. And I want to bring this down to about even with the center of the magnet. We're about right there. Okay. Y plus. Just line up the 2 dials on 0. All right, that is going to be our Y0. All right, so this is going to be for our Z0. The Z0 for this side is just going to be this top surface, so we're using our Edge Technology touch off there. That's exactly 4 inches once we line it up on a 0. And then that's the face mill we'll be using for this op. It's a 3-inch diameter face mill from Tungaloy. The Do Quad is what that one's called. All right, so that's going to be our Z0 right there on G54, and then I have to subtract 4 inches from that measurement there as well. I just made another error cut, and I think our program is finally ready to go. So we're going to make a modification on our Z, get it back down to 0, and go ahead and get this part run. So I did modify my program so that once it finishes, it moves to X60 and gets it out of the way so we can get in there and look at it. And also what I had figured out that I had done is on our 41/64, which is a drill we're using for this op right here, I had forgotten to actually attach that to a tool pocket number. And in Fusion, if you don't do that, it automatically drops it into the next slot. And it had set it as tool 12, which in here I had tool 12 letter U, but the program itself selected this tool 12 letter U, which is going to be for the next fixture that we'll be doing. So we've got that fixed up, we've got our proper drill in there now, and we are ready to cut. So let's get moving on this. All right guys, here we go. Got my Z adjusted. Start from the beginning here. Sounds like that corner's low. We may have to, let me make a couple passes to see what's happening, because it looks like we're not down there on the, yeah, it's just, it's not flat, that's the problem. It's cutting now. Definitely a little heavier on that side. I'm going to speed this up by about 10%. 110% feed rate. I've got that face mill running the recommended speeds for that insert with a, I can't remember now, I think it was a 6,000 per tooth chip load on it, but we're only running about 840 RPM. So this will be my first time machining parts like this using magnets. I do have a magnet that we've used, the kind of magnet you'd use on a surface, a surface grinder. And we only used it for a few jobs specifically for that. So you can see the chips are probably going to try to pile up near where the magnets are. That's one of the things you have to keep consideration with these. But for facing and drilling option, shouldn't be a problem. So far it's just that corner that it's not milling. So we may just let it continue on and see what it's going to look like after our 20,000. All right, guys, that's it for the face milling. I am going to, I'm going to jump over into manual mode so that I can move it down. We'll clear those chips off of there, and I want to inspect it and try to determine if I need to face this off again. So we're just going to move you manually out of the way, and I'll make sure that camera is nice and clean too. Take a peek at our finish here, get these chips brushed off. looking pretty good myself. So the plate looks really good. It's got a nice smooth finish. That tung alloy face mill did a really great job. It doesn't have the shiniest, pretty finish in the world, but I'm telling you, this is super smooth and I'm real happy with it. So this is our low corner, and what I did was I just made a little X approximately where our drilled hole is going to be, because I wanted to see where the stud, the flange that's going to be pulling down, and it's going to be right there in that milled section. So I think I'm just going to leave this corner alone, not take any more off of that, and just continue on with the program. But I wanted to show you, so here's another use for our surface gauge, because I wanted to see how far that corner dropped off there. So you can use your surface gauge with an indicator on there, and got it zeroed out on our milled area. And if we come over here to this corner, it drops off 10 thousandths. So we'd have to take at least another 10 thousandths to clean that whole plate up. But since this is just a mounting surface right there, and our stud will be pulling down in this area, I think we're going to be fine to leave this area out here untouched. All right, so we're going to go ahead and reset and finish out the bottom side with our drilled holes now. Okay, let's keep it going. This is our 1/2 inch spot drill, 120 degree spot drill. Just going to do the 4 outer holes. That is 60 thousandths deep. All right, this is our 41/64 reduced shank drill. This is Chicago Latrobe high-speed steel, 118 degrees. We're running 90 surface feet a minute and a feed rate of 10 thousandths per revolution. Went through that 1 inch plate just like a breeze there. Great job. I am running a PEC cycle there, so I've got it set to a chip break every 125 thousandths, so every 1/8 of an inch it breaks the chip. That's an amount that's really working well for me, so you don't make the helicopter chips. And those high-speed steel drills, I am really figuring out for this job shop work. It's great having all of those high-speed steel drills around here, just like I've always used, and not having to invest in all the expensive carbide drills. For job shop work, the high-speed steel drills are still very economical and the way to go. If we're making thousands of parts and thousands of holes, yes, we need to get a carbide. So I believe the next up, that's going to be our 9/16. Now this is a carbide drill. This is a Walter. It's going to be a Walter Titex. It's going to drill a hole right in the center. Got through spindle cooling on this. It should be just a straight plunge all the way through. Beautiful. Next up is chamfers. Again, for our chamfers, this is a 3/8 diameter mill drill. It looks like my 9/16 hole didn't go all the way through there. There's coolant in it. Might have to make an adjustment on that, rerun that. Yeah, we didn't go all the way through with our 9/16, but it's got to be right there. It was just that's got to be an error on my part. Let's see. Yep, I can feel that it was just about to come through the bottom there. So I need to make an adjustment on my program and just drop that down another, I don't know, 100 thousandths, and that should go all the way through there. So I'll just rerun that program just on that line, change that to that tool, run the drill, and I'll stop the program, and that should be good to go. But everything else looks good. Our holes are good. Our chamfer's good. I'm telling you, the high-speed steel drills are killing it on this job shop work like this. I love it. I made an adjustment on our program and sent our drill another 16th, and that cleared that up. It wasn't a problem right there. This feels really nice. Really nice finish on that. Nice and silky smooth. So I believe what we're gonna do is just go ahead and flip this guy over. I'm gonna repeat my setup, center it up on there, get it bumped nice and straight, and then we'll use our coaxial indicator to find the center of that guy right there, and that'll put us in the middle of our workpiece there. So I was gonna show you on our program, I went down here where our 9/16 drill is. I went to that line 116. There's our Z depth. It was like negative 1.04. I just changed it to negative 1.1, so sent it 60 thousandths deeper, and that worked out just fine. I'm learning how to get in here and modify our G code on the flex, where we can just do it right there instead of having to tweak it on the Fusion side and then insert the USB and re-upload it. Just make your tweaks right there. Still learning how to do all this stuff. All right, so we're gonna go ahead and get this guy flipped over and get it all indicated again. Okay, we got the plate flipped over. We're gonna get it bumped true. About a 1/16 too far on this corner. -5. So I'm just using my magnets as my reference there. Let's see here. Let's come that way. -5. We can reset that. There's our 0. +2. 0. That looks good enough to me. 0 and 0. I mean, 1/1000ths here or there. Remember, flame cut edge right there. And if anybody's curious, if you might be saying, well, that's not perfectly true with the hole pattern that you just drilled. And that is true. You could take some gauge pins and stick them in these holes right here and use like a straight edge or a parallel and indicate that if you really needed to make sure that this hole pattern was indicated dead nuts 0. But we're not worried about that because we have a symmetrical hole pattern, and the machining that we're going to be doing in the center here really has nothing to do with the alignment of where these 4 holes are, because it's just a pocket for it to sit in, and we're going to be lining up on this hole in the center there for the center of our work, and then Z'ing off this surface right there. So indicating the edge of that is going to be perfectly suitable. So I'd call that good enough. Just going to check it one more time. It looks like it's about 0, and it's about 0 right there. So let's move our gauge off over here, out of the way, put it on the toolbox. And I'll grab the T-handle. We'll go ahead and engage our magnets. It's there. So of course I'm a little nervous about this setup since it's the first time using magnets, but those things should be plenty strong enough since we're using 4 of them with 2,600 pounds of pulling force. So we're going to be doing a pocket here and then another pocket right here, and then we'll have a hole pattern drilled in there too. That's just going to be clearance holes for whenever we drill the aluminum, and our drill comes through, it'll just have a clearance right there. We're going to have 4 holes drilled and tapped out here for our hold down clamps, and I will show you guys the Fusion 360 program first. We'll go ahead and I'll show you guys the simulation on Fusion on what we're going to be doing here, so you guys can see it before we get started on it. All right, so this is going to be looking at the top of our plate, which we're getting ready to mill here. I'll just kind of talk you through it. We're going to start off with a 2D adaptive and machine a pocket in the center, and that's going to be clearance there so that whenever we stick our aluminum on there, this pocket will be open and we can machine our aluminum without touching the steel. All right, the next one is going to be another 2D adaptive, and that's going to machine the pocket here that the aluminum is going to sit down in. All right, so we'll use the face mill. We're going to use a tongue force rec in the center. We'll use our big face mill out here to cut that. 2D contour, that's going to be a 1/2 inch end mill to machine that diameter to precision fit. All right, then we got a spot drill, so we have 4 1/2 inch holes that are going to be drilled and tapped out there. That's going to be for our clamping bolts. 27/64 tap size drill, 9/16 carbide drill. These are going to be our clearance holes for the hole pattern that gets drilled through the aluminum. So those are just to open up the steel to clear the drill. All right, I got those 3/4 deep, so we won't be going all the way through with those. They only go down 3/4. All right, and then 2D chamfer. So that's chamfering all the holes, chamfer the 1/2-inch holes, and then we're going to chamfer that counter bore there. And then the last thing, we got a 1/2-inch tap that we'll be using to tap those 4 holes. And that'll be it. We can go ahead and hit simulate on this and go ahead and give you a run through. I'm going to speed this up just a little bit. So that's the center. That's the 1-inch tongue force rect. Then we'll switch over to a 3-inch face mill and mill that pocket out using 2D adaptive. Then we're going to do a 2D contour with a 1/2-inch carbide end mill. I got 2 passes there, so hopefully it'll finish it on size. We use our calipers to measure it. Spot drill and drill, chamfer, chamfer, and then we're going to do a chamfer around the ID and that diameter there as well, and then chamfer those 4 holes, and that's it. That's all it is to it. It's easy, right? Let's see if we can go make it happen. All right, this is how I'm going to get the center indicated there, and that's why we put that hole. So we're using our Blake coaxial indicator right here. All right, so let's see if we can make some little movements. I'm just using the hand pendant, and we're just gonna, oh, you know what? I didn't tighten that chuck, so let me grab my key and give that a snug there. I don't want the indicator trying to come out. About 21. I'm gonna go down to tenths. That's about 20. So all I'm focused on right now is in our Y direction. Just moving it in a few tenths. So that's pretty close. Now I'm going to go to X. So it's low on that side, heavy on that side. So we need to go that way just a little bit. I'm going to move over to X. Let's just take it to the 20. Let's see what happens there. About 1/1000. That's within a few tenths. So there's nothing wrong with that right there. We're going to call that our XY0. We're going to go ahead and do that on our G54 work offset. Get that done, and then that finishes up. And we've still got to touch off on our Z there as well. All right, using our 9/16 drill to set our Z depth. I'm using this because that H value is still activated. All right, we'll get that set right there and we should be ready to go. All right, so I just went through a couple of air cuts, made a couple of minor tweaks to our program there. Everything is looking good, just making sure that all of our tool paths were looking right. Looks like we're in the center of the plate like we should be, and that we're going down to the proper Z depth. So I think we're ready to roll with this. My biggest concern with this job here is the magnets. You know, I've never used these before until now, so I've never proven them myself, but I'm hoping that, you know, each one of these guys have 2,600 pounds of pulling force. So I'm hoping that between the 4 of them, that's going to keep that keep the plate in place and keep it from shifting and moving, and we're not going to have any crashes or damage. So like I said, that's my biggest concern right now. So we don't know until we know. Let's find out. So everything's looking pretty good. The first operation is going to be the heaviest milling there. We're going to be using a tongue force rack, 1-inch diameter. That's a high feed mill. We're going to do a helical pattern down, ramp down to our bottom depth, and that's going to be a total of, I believe it's 3/16, about 180 thousandths deep. And then it's going to do a helical tool path around to clear that out. and then we'll come in with a 3-inch face mill to do the counter bore that the aluminum disc is actually going to sit down in and register on. And then after that, we've got some drilling and tapping to do, and then that'll be it. So hopefully we're going to have a good run here. So we'll load you up on the spindle. If I need to clear the lens between each tool pack, we're going to take care of that. You know, it's difficult to get really good footage inside these machines. I'm going to do the best I can to show you what we're doing. So let's get moving on it. Okay, I think that went fine. There was a couple loud noises, but that was a chip that got hung up in the auger down there, just unrelated. I'm gonna bring you to me and go ahead and clear that screen off, and then we'll continue on with our program. Going in with our 3-inch face mill. This is the Tungalloy Duquad square insert mill, 60 thousandths depth of cut. We are running this at a feed rate of 28.5. I'm real happy with that. I think we succeeded. We didn't have any kind of problems with our plate shift, and everything sounded really good. So let's clean the screen, reset, and continue on. This is going to be a 1/2-inch 6-flute carbide ML. We're going to be doing a 2D contour to clean up that wall. And I should have cleaned the chips off of this, didn't think about it till now. So hopefully this is going to be good to go. Just a really light 10 thousandths radial cut, same depth as the face mill. And hopefully this is going to give us a precision fit on our aluminum disc that's supposed to sit down in there. 2 cuts, 10 thousandths each on the radial. once again, we'll clean the screen. I'm gonna brush all them chips off and then we'll carry on. Half-inch diameter spot drill for our half 13 tapped holes. That is a 120-degree spot drill. 60 thousandths deep. .27/64 carbide drill, and I just realized that I made a mistake. We didn't need to spot drill those 4 holes there using this drill. Hopefully it's gonna work. Let's see. Sounded fine. Going down 3/4 of an inch. Just love seeing those drills work. So fast and smooth. This is a 9/16 carbide drill. We're gonna drill our hole pattern in the center. This is just gonna provide clearance for the drill that we'll use to drill the aluminum. Those Walter Tytex drills are awesome. This is our 3/8 diameter mill drill. We chamfering all the holes and then the edges for the counterboards. Just a deburr there. Okay, last operation. This is our half 13 spiral flute tap. All right, looks good. Microfloat doing the job, and we gave ourselves a 1/4 inch clearance in the bottom of the hole. Beautiful. That is it. Real happy with this. I think everything worked out good. No crashes, no broken tools. Plate stayed where it was supposed to be, so Our magnets are working just like they're designed to. Now, of course, we still got to measure this counterbore here and see if it is cut where I designed it. It's supposed to be 20.502. And it should give me 3/4 thousandths clearance for our aluminum disc to drop in there. And then, of course, again, this is just clearance. So when we come in here and machine our aluminum, we're not hitting the steel there. Our threaded holes are great. I'm going to take a bottom tap there and run it down into the holes just to get them a little bit deeper. I was being really conservative with that just because of the fear of bottoming out the tap and it breaking off in there. So I do want to run the threads down just a little bit further. Take care of that, and then we'll come in here and we'll measure this with our vernier calipers. All right, we got Dad's Starrett vernier calipers right here. Let's just, we'll use this hole and this hole as our reference there. And I will mention that I cut this without using any kind of cutter compensation. It just thinks that the cutter is 0.50 in diameter, and we gave it a diameter to machine it to. Let's see how close we actually got to that. Don't have much of a step there to catch, but we got enough to measure this here. I made that chamfer a little deeper than I should, but it's all good. It's going to work good. That feels like a good touch right there. So I'm going to measure the top, the inside, and it looks like I am actually getting 20.501. So I'm reading the 1,000ths line past the 0 on the top. So it looks like we've got this machine, if I'm correct on our feel right here for our measurement, we're 1,000ths under what my target was, but that's why I gave it 2,000ths over. I figured it was going to be really, really close on size, and that's why I turned the aluminum disc 2,000ths under, so that I could sure that when we machine this, that it should drop in, and it should. I'll go grab one of them, and we'll set it down in here and just to be sure. Make sure you get all these chips out of here. I'll give this another puff with the compressed air. All right, we've got one of our aluminum rings here. Is it gonna fit? It should. Push it in. There it is. And I can feel it's got that 2 to 3 thousandths clearance there, which is perfect. Absolutely perfect. Awesome. I think that's going to work really well. So this is what it'll look like. You know, we're going to have a strap clamp in these 4 corners right here holding the plate down. These are going to be for our hold downs for the bed rails. And then we can come in here and do our machining to get our counter bore. And then we're going to move it over to the second fixture so that we can machine that's outside. Here's our sample pattern that we're copying. You see what I'm talking about. We set that on there, line that up on the OD. Now you can see what we're going to be machining here in the inside. And you can also tell that we've got plenty of material on this inside that we're going to be machining out. I know I got people that were concerned that this ID was running way out more than it should be to be able to clean it up, but I think it's just fine where it's at. So I'm looking forward to continuing moving on and seeing this guy get machined. Awesome. Real happy with the results we're getting today. So as I had mentioned, I'm real happy with the results that I'm getting today. I'm happy with the way the fixture turned out, the way it looked, all of our fits, everything was right there spot on. So this guy is ready. We're going to be removing it from the magnets and setting it down over here and getting it bolted down, and it should be ready to go. That's telling me that our earth chain magnets are doing their job. I was concerned that we wouldn't have enough downforce or pull to hold this plate for that mill in there, but it proved that it's going to do exactly what it was designed to do. I think they're going to be extremely valuable for plate work like this, and that's why I wanted to invest in those magnets there. for being able to take some of these jobs that's going to be coming in with this plate steel and be able to easily hold it to get some of our machining ops done on it like that. And maybe we'll be able to use these on the other machines there as well, maybe the Milltronics, or even have something on the manual mill. It'll be really fun to have that for whatever mill that we need to set them up on. All right, so we're going to move on to the second fixture plate. We're going to get this guy over here out of the way. I've got to reposition these magnets and get ready for our second fixture, but we're going to begin the second fixture over on the American pacemaker. It's really simple facing ops that we'll do there, and then bring it over here to the flex to machine our hole pattern in there. And then once we get that done, we're going to be ready to start making some aluminum chips. All right, I hope to see you on the next video, and I hope you guys enjoyed.